Francine wakes up in the morning and she is very tired. She gets her cup of coffee and then goes to the refrigerator and adds cream. Then she realizes she accidentally added soy milk instead of cream, which she doesn't like very much. She needs to get the soy milk out of the coffee. Can she do it? Let's talk about equilibrium. Things tend toward equilibrium. This is the most probable state in which to be. We talked about thermal equilibrium, where the temperature will adjust until it reaches the same temperature on both sides of a barrier. With thermal equilibrium, we know that the heat will travel from the hot area to the cooler area until these two containers reach the same temperature. These are examples of irreversible processes. We know that heat will only go from a hot region to a colder region, not from a colder region to a hotter region. This is an irreversible process. You can stir the cream into your coffee, but you cannot stir the cream out of your coffee. Talk about entropy. This is the probability that a certain state of a system will occur, and this determines whether something is irreversible or not. If we look at this system, we have particles that are all lined up very neatly. This is unlikely. All the particles have to be precisely arranged, and if any particle moves, it'll be easy to notice. Things start to move a little bit in the second section. This is a little bit more likely. And in the final section, things are moving in much more disorder. So as you go down, we have increased disorder. As you go down, we have increased entropy. That means it's more likely that things will occur in this frame, in this example, than in this example. And we also have increased probability as you go down. So this arrangement is much more likely to occur. It has the highest entropy. All of this can be summarized by the second law of thermodynamics. The second law of thermodynamics says the entropy of an isolated system never decreases. It either increases until the system reaches equilibrium, or if the system started in equilibrium, it stays the same. So we're not going to be able to make things more ordered. We're going to only make them more disordered. Entropy is why heat engines are never 100% efficient. The entropy that's created in the heat engine is removed and then put into the cold reservoir. So when we don't think about thermal energy, then we do have reversible processes. So when we've talked about conservation of energy in a system where there was no friction, then you can have a reversible process. But when you include thermal energy, you will see the entropy of the system increase.